Dear students, in the previous video lecture, we discussed about context-free language and its grammar called context-free grammar. And we also learnt the production rule and its grammar VTPS. In this section, we learn some simple topics, something like derivations using a grammar, LMD RMD, leftmost derivation and rightmost derivation. First of all, what is derivation? Don't get shocked with the big word derivation. It is nothing when you see our previous video. The process of obtaining the strings of terminal T, variable V, start symbol S, and the production rule P is called derivation. What is derivation? The process of obtaining the string. That is, this is the string. This is the process to obtain the string. Am I right? This is the string I need. Is the process to obtain that particular string. This particular process I am going to call it as derivation. That's all. So it's very simple. It includes V, T, P, S. Everything is included here. That's what we mentioned. And we will give one more concept called sentence, or we used to say sentential form. The string W obtained from the grammar VTPS by the derivation. Each string in the derivation is called a sentence. It's not a big deal. This is the derivation, you know. There is a string here, there is a string here, and finally you will get the required string. These are all temporary in-between strings. These all are called sentences. What do you mean by sentences? Each string in the derivation is called sentences. Nothing else. The derivation using grammar for arithmetic expression. How to bring derivation for arithmetic expression? What do you mean by arithmetic expression? Addition, subtraction, multiplication, division, all these stories. There are some predefined expressions are available. What are the predefined expressions? Something like plus, something like minus. These are all predefined. Multiplication, division, and brackets. These all are predefined derivations. Using this, we can create some mathematical calculations. So that is what we are going to discuss. Hereafter, S is a variable, A is a variable, B is a variable. I will not use all these variable. Hereafter, temporarily, I am going to use E. It is not a rule. You can use whatever you want. I am going to follow E. There are some terminal symbols A, B, C, epsilon, plus. Hereafter, I will mention that as ID. Just a simple notations, just for clarification purposes. So, what is plus? E becomes E plus E. E becomes E minus E, multiplication, division, power, bracket, ID, like that. There are some ready-made expressions are available called predefined expressions are available. Using this particular expression, we are going to do some calculations here. What are the calculations? Leftmost derivation and then rightmost derivation. In the derivation process, if the leftmost variable is replaced, what is that particular meaning? Sir, I want to create this particular equation, arithmetic equation, ID plus ID into ID, or 5 plus 8 into 2. Whatever may be, just in general. I don't want to use the number, then you will start doing the calculation. So I am preferring ID. Try to use these symbols, arithmetic grammar, and bring out this. Okay, wait a minute. I will discuss LMD later. Don't worry. Don't have a doubt. So, start from plus symbol. E becomes E plus E. E plus E. This is the result. Now, this is my starting point. Remember, my target is to reach this. Sir, what I should do? This plus came. This E later I can replace by ID. But sir, I need multiplication. Don't worry. This E, can I replace by E plus E? E star E? Yes, I can do. If that is the case, this E I am going to replace. Am I right? Okay, come on. Replace E replaced by E star E. No, not allowed. What is that I mentioned? LM. What is LM? leftmost derivation. What is leftmost? There is one variable. There is one variable. You should prefer leftmost variable only. In the derivation process, if leftmost variable is replaced, every step hereafter you should give concentration for left and then right. Now you see, you started replacing this, not allowed. Then that derivation is called leftmost derivation. What is that, sir? Don't replace this. First you replace this. Sir, what I should do? No problem. You replace by ID. That's what I did. E I replace by ID. Now left variable is replaced. Now there is only one variable. Now you can go ahead replacing this E by E star E. Done. Now your aim is to bring here. Am I right? Okay. Come on. Replace this E by ID. Yes, I hope you got it. There are two variables. Which variable you should prefer? LM, leftmost. So this variable only. Replace by ID. Then this variable replace by ID. That's all. So using this ready-made arithmetic grammar, I am asking you to bring this particular expression, but whenever you use the variable, you are going to replace by leftmost E. Sir, can I use the rightmost variable? Yes, you can do it. That is nothing but rightmost derivation RMD. Now we will do the same example. Come on, ready. Now you can remember whatever I told in the previous derivation. Can I replace this by ID? No, sir. First you finish this, sir. RMD. Two E's are there. Rightmost E you replace by E star E. Done. Now there are three variables are there. Which E I should replace? This E or this E? This one. Why? Rightmost. Now in the derivation process, this is the derivation process. If the rightmost variable is replaced in every step, then the derivation is said to be RMD. Now this E you should replace. What you should do? Make it as ID. Then this rightmost, make it as ID. Then this rightmost, that is pending, make it as ID. Now this is the difference between LMD and RMD. What is parse tree? It is also called a derivation tree. What is the tree representation or graphical representation which we discussed in the previous subjects, courses? Okay. Now parse tree I am going to create. Even there also LMD is available. Now try to bring this particular concept using the same arithmetic expression. Now this is your first work. E become E plus E. What do you do? The starting E is here called a root. Replaced by E plus E. That's all. E plus E. Remember, my target is going here. Now there are two E's are there. Leftmost you should prefer. This fellow. What you should do? Replace by ID. Done. This side what we did previously in derivation. Now I am going parse tree. Okay. So parse tree. This is called ID. Next come to this E. What is that? This E. What you did? Can I remember? Sir, I replace this by E plus E as E star E. Yes. Now do the same work here. E star E. Done. Next what you did here? LMD, you know. This U replaced by ID. Yes. Now this U you replaced by ID. Yes. Now this E you replace by ID. Whatever you did in derivation, I am doing here. Now who is E? Parse tree. Is it a graphical representation? Yes. This is graphical representation of your derivation. Okay. It is graphical representation of the derivation. The derivation process is shown in form of a tree. Such a tree is called derivation tree or parse tree. Now who is E? Root. Who is all these fellows? Leaf. Okay. Now these all are called leaf. The ending point called terminals. Ending is called leaf. Now in the leaf, you should start read from left side. Okay. What is that left side? ID plus ID star ID. ID plus ID star ID. This is the way you are reading is called yield. Okay. Now who is root? The starting point. The root node is always a node indicated by start symbol. Who is leaf? Terminal. The leaf node is always called terminal nodes. What do you mean by yield? Yield is a derivation result obtained by reading the leaves from left side to right side. Now the parse tree also I can show in RMD concept. Come on, you started. Now two E's are there. This U E replaced by E star E. Am I right? Now first you replace E plus E. Done, sir. Then this E you should replace by E star E. Done. Okay. Now there are three E's. 1, 2, 3. Rightmost RMD, you know. This E, that is this E, replaced by ID. There also. Then this E replaced by ID. Here also you replace by ID. Then last, this E replaced by ID. I am going in RMD. That's all. Now these all are called leaf. Now start read from the left side. Yield is ready. Okay, the same definition holds good here also. Let us see some examples of LMD and RMD. Now they will give some production rule and they will say bring this string. Using this production rule, bring this string. That is what your duty. Bring both LMD as well as RMD. Now I am going to show you LMD. Always start from start symbol. No other choice, AB. So since LMD, I should replace this A, not this B. Okay. Now this A I should replace. Carefully see. This A I can replace by AB or SA. What I should do? You think. This is your answer. If you replace this A by this fellow, then I hope AB is better. Am I right? If you replace this A by AB, this A by AB, I can go to the next step. Then what you should do? You start guess. If you replace small letter A, capital letter B, again capital letter B will come. Am I right? Then this B you can replace by SB because I need B, and that S can be killed using epsilon. Again this B can be replaced by SB, that S can be killed by epsilon. Or else this A you can replace by SA and kill S by epsilon. Anything you can do. Okay, it's left to you. Now I am going to replace the first method. AB I made it. Okay. Now ABB. My target is this ABB. I am having capital letters. LMD. This B only you should touch. But make sure you go here. Either BA or SB. Okay. Now you should go ahead in that way. Now B you replace by SB because I need one more small letter B. Now what you should do? LMD. This S is there, this B is there. Now itself you guess, kill this S by epsilon. Okay sir. Then this B replaced by SB again. Then again kill S. Kill it by epsilon. Then this B replaced by SB. Then again this S kill by epsilon. Okay. Now using the rule, using the start symbol, how you are going to bring the given string is your challenge. At the same time, you should prefer LMD. Can I do the same work using RMD? Yes, sir. Now you replace from this B. Start from B. What I am going to do? I can start from this SB also. Nothing wrong. Again, this S I can kill or I can replace. I am killing. Now this A is there. I am going RMD. Okay. This A is there. I can go for AB. And then you can replace by SB. Like that I can do. AB, and then capital B you can replace by SB, then S you can kill. Okay. Now both the way I can bring the answer, but here I brought LMD, here I brought RMD. We'll have one more problem, AA, BBB, A, using these four techniques. Okay. Now have a look on this. I will always start from start symbol. Ready? Now what I am going to do? AA, AB, BA, BB. Okay. A I replaced by AA. S I replaced by AS. Then again A replaced by BB. S replaced by AS. All the rules are available. A replaced by BA. Yes, you kill. Okay. Now what is the target I did? Since I am having 4 terms, double terms I have replaced. Okay. Now my aim is not doing LMD. My aim is doing derivation tree. That's what I just skipped all the stories. You can go ahead. Now parse tree. S is the root, replaced by AS. Then this A replaced by WA, and then S is as it is. This S replaced by AS. This A replaced by WB. This S replaced by AS. This A replaced by BA. This S replaced by epsilon. Now if you read the leaf, I will get all the result, but don't read epsilon because it is null. Okay, so I got the result. Who is he? Parse tree. So are also called derivation tree. Now I am going to give the same parse tree in LMD for bringing this expression A plus B star C. Now let us start here. I will start parse tree directly. Start from root E. I am going to prefer LMD, so I am going to prefer E plus E also I can prefer. Then LMD means this E. So which means I need A. Replace E by A. Then this E I should replace by E star E. Then this E I should replace by B. Then this E I should replace by C. Ready. The answer is ready. LMD. Can I do the same by RMD? Yes, you can do. Or also I can start with E star E also. Okay, you can do. But they mentioned it is LMD. I am going to prefer LMD only, but I will start with E star E. LMD, this L. Okay, this left side. E plus E. Done. Then E, E, E. LMD, this L. Okay, this left side. A. Then this fellow. B. Then this fellow. C. Now also the answer is same. Remember, my dear, this is parse tree using LMD. This is also parse tree using LMD. You can also do RMD. That is not a matter. Sir, you are doing like this, sir. Now have a look. Parse tree LMD. Parse tree LMD. Both are getting same answer. But do you feel the diagram remains same? No. The diagram is different. Two different parse tree for the same grammar. If you give these two parse tree to the designer, they will ask a question. Sir, I should use this or I should use this. Then I should explain. It is having a less speed. This is having more speed. Something like this. So you started giving trouble to the designer called doubt. We call it as ambiguous grammar. Hence, if you have two different parse tree for the same problem, we call it as ambiguous grammar. Then what is unambiguous? A grammar is considered to be unambiguous if every string in the language has only one valid parse tree. Whatever you do, one tree only I will get. Then it's called unambiguous, so that the designer will not have any doubt. With this, I would like to conclude this particular derivation series called LMD, RMD, and also I discussed parse tree, and I also discussed two different parse tree means ambiguous, and the same parse tree is called unambiguous. And you can also see two different derivation, and if you have two different derivation for the same result, then it is also called ambiguous grammar. With this, I would like to conclude this particular video lecture. Thank you.